everyone, so today we're going to be doing notes on section 5.2, which is solving systems of equations using substitution. So there's three different ways to solve a system. Last time we looked at solving them by graphing. Today we're going to look at substitution, and then the last one we'll look at next week is using elimination. All right, so go ahead and pause this real quick to write down the steps, and then I will walk you through them. All right, so step one for solving a system using substitution is to solve one of the equations for x or y if it's not already done for you. So a lot of times you'll be given an example that already says x equals or y equals, but if it's not, then you'll solve for x or y to just rewrite it. Step two, substitute the expression from step one into the other equation and solve. Step three, substitute the value that you got in step two, so either your x or y value, write a little note for that, the x or y, into one of the original equations and solve to get your other letter, and then you'll write your final answer as an ordered pair. So let's go ahead and look at an example. So we're given two equations, and they're both y equals and then other stuff. So step one is already taken care of. It's already set equal to, or it already says x equals or y equals, and they both actually are. So what we can do now is, let me grab a different color, is I can take all of this. So y is equal to all of that. I can take that and plug it into the other equation where I see the y. So that's what I'm going to do with this next step. So I'm going to write 2x plus 5. So I'm plugging it in where I saw the y, equals all of this, the negative 3x minus 10. Now I can simplify, so I want to get all of the x's together. I personally prefer to get them all on the left, so I'm going to add 3x to both sides. So then I get 5x plus 5 equals negative 10. And then what do I do next? Good, if you said subtract 5 or move the 5 to the other side, then you are correct, because we want to get this x term by itself. And then lastly is to divide both sides by 5. So x equals negative 3. So I've gotten half of my answer, but I still need the y value. So this is where that final step comes in. I'm going to take this x value and plug it back in to either equation. So we are going to plug in x equals negative 3 to either equation and solve for y. All right, sorry for that super long awkward pause. At least it felt like a super long awkward pause on my end. My phone was ringing, but I was waiting to finish writing this sentence in pink before I paused the screencastify. Anyways, all right, so I'm going to choose either equation to plug this back into, either the top one or the bottom one. Me personally, I would choose to plug it into the top equation because all of the numbers are positive, but you'll get the same answer either way. So I'm going to plug it into the y equals 2x plus 5, and I'm going to plug in the negative 3 for x. So y equals 2 times, plug in negative 3 for x, plus 5. So y equals negative 6 plus 5. So y equals negative 1. Now that I have the x and the y value, I write my final answer as a coordinate point, which is negative 3, comma negative 1, x, comma y. If you had plugged in your x value to the second equation instead, you would have still gotten y equals -1. Let's look at another equation, or sorry, another example. Are either of my equations x equals or y equals? Good, you should have said yes. The second one says y equals, so step 1 is already taken care of. What I'm going to do now is take this whole thing that's equal to y and plug it into the first equation where I see the y. So I'm going to have 4x minus 2 times all of this stuff that I'm plugging in for y. So the -5x plus 13. Close those parentheses, equals 16. What do I do next to simplify this? Good, you should have said distribute or distribute the -2, because we need to simplify this. So when I distribute, go ahead and pause this video, finish solving for x, and then push play when you're ready to check your answer. Go ahead and check your answer. Make sure you got x equals 3. And I wrote all of the individual steps so that you can check your work in case you made a mistake. Now we're going to plug x equals 3 into either equation and solve for y. Now the stuff that I'm writing in pink, I'm just writing that so that when you go back and look at your notes, you know exactly what I did and why. You do not need to write this on your work for homework, and I will not write this on the answer key for the homework. It's just here in the notes so you know exactly what's going on. So again, you can choose to plug it into either equation. Now this time, since the second equation already says y equals, and I'm trying to solve for y, I'm going to plug it into the second equation. The y equals -5x plus 13. So I'm going to plug in 3 for x. And then finish simplifying this. So y equals -15 plus 13. So y equals -2. Now that I have my x and my y value, I write my final answer as a coordinate point, which will be 3, -2. For this next example, are either of my equations already set up for the first step, the y equals or x equals? Good, you should have said yes. So this says y equals. I can take this value and plug it in where I see the y down here. So I'm going to have 1/2 x minus 2 equals -3x plus 5. Now, if you wanted to continue solving it and leave the fraction in here, you absolutely can do that. Myself personally, I want to get rid of the fraction just so I don't have to deal with it at all. So what I'm going to do, what would I multiply 1/2 by to make the fraction go away? Good, you should have said 2. So I'm going to multiply the entire thing by 2. So the left side of the equation and the right side of the equation. So 2 times 1/2 is 1. Those cancel out. And I'm left with just x. 2 times -2 is -4. Equals 2 times -3x is -6x. And 2 times 5 is 10. Now I can still solve this, but I don't have to deal with any fractions. So I'm going to add 6x to both sides because I need all of the x's together. And I prefer to put them all on the left. So 7x minus 4 equals 10. What do I do next? Good, you should have said add 4 to both sides or move the 4, something along those lines. And then lastly is to divide both sides by 7. So x equals 2. So even though my equation started out with a fraction in it, my final answer is a whole number. And then lastly, plug x equals 2 into either equation and solve for y. So again, you can choose which equation. I know if I plug in 2 to the first equation, it's going to make the fraction cancel out regardless, but I'm still going to choose the second equation just so that I don't have to deal with a fraction. So y equals -3 times x, which we're plugging in 2. So y equals -6 plus 5, which is -1. So our final answer is 2, -1. And again, we are writing our answers as coordinate points, as an x, y coordinate point. All right, I want you to try an example on your own now, but I'm going to help you get it started, and then you're going to finish the problem. So are either of my equations x equals or y equals right now? Good, you should have said no, they're not. Which means we have to do step 1. We have to make one of them say x equals or y equals. Which equation is going to be the easiest to do that with? Good, you should have said the top equation or the first equation, because this one already has a y that has no coefficient in front of it, which means there's no number multiplied by it. So what I can do here is just subtract 2x from both sides, and then it'll say y equals. So y equals -2x plus 10. We rewrote it. Now that this says y equals all of that, and my second equation, I want you to go ahead and push pause, finish solving this problem, and then push play when you're ready to check. All right. How many of you started solving this and then panicked when all of your x terms disappeared and you went back and double checked and went, oh my gosh, what happened? What happened to all my variables? What did I do wrong? You did absolutely nothing wrong. But I wanted you to see what it looks like when you have to rewrite an equation so that it says y equals or x equals. This happens to be a special case where when you plug it back in and start to simplify, your x terms cancel and you're left with just numbers. So this takes us back to solving equations when all of your x's cancel out and you are left with a false statement. When the statement is false, will it be no solution or infinite solutions? Good, you should have said no solution. It is no solution. If it was a true statement, if it was 20 equals 20, or -3 equals -3, and it's true, then it would be infinite solutions. So what this means by saying no solution is there is absolutely no coordinate point in the world that you could choose that would work in both of these equations that we were given. Absolutely no answer that would work. All right, one more example. I want you to try this on your own. It is not a special case. You will get an XY coordinate point as your answer. So go ahead and push pause, and then when you're ready to check your answer, push play. Go ahead and check your answer for this last example. So I plugged this in where I saw y in the second equation, simplified and got x equals -1. Then you can plug that back into either equation to solve for y. I chose to plug it into the first equation because this one is already in the form y equals, and I'm trying to solve for y. So I plugged it into the first equation and got 8. And then you write your answer as a coordinate point. All right, that is the end of our notes. Have a good rest of your day.